Welcome to Lesson 4 on isomers. Our lesson objectives: identify isomers of alkanes, alkenes, and alkynes, and construct isomers of alkanes, alkenes, and alkynes. Isomers are substances that have the same molecular formula, meaning the same number of carbon and hydrogen atoms, but a different structural formula, meaning the atoms are rearranged differently and therefore they have different properties. So for example, looking at these two structural formulas here, they have the same molecular formula, which is C4H10. So they all have the same number of carbon and hydrogen atoms, but a different arrangement of those atoms. So the structural formula is different, and you'll notice the names are different as well. So here we have 5 different structures, and we want to match the isomers. So what we're going to do is look for the same molecular formula, same number of carbon and hydrogens, and a different structural arrangement. So we see that the top 2 here are both isomers of each other. They have 4 carbons and 10 hydrogens, but they have a different structural arrangement. They would have different names and different properties. So this one here, 1, 2, 3, 4, this is going to be butane. And this one here, 1, 2, 3, this is going to be 2-methyl propane. For the bottom, all 3 of these are isomers of each other. They all have the same molecular formula of C5H12. Let's check your understanding. Can you identify the isomer? Now let's look at drawing an isomer of an alkane, all single bonds. What we're going to do is going to use the same molecular formula for our isomers, and we're going to draw a different structural formula. So if the name of the compound is different, but it has the same molecular formula, we've created an isomer. So here's an isomer of hexane. Hexane is 6 carbons. It's an alkane, ane ending, so all single bonds. And we want to create an isomer of this. So the first thing we do is we determine the molecular formula. Since we have 6 carbons, it's C6, and we have 14 hydrogens. And so to create an isomer, we're going to use the same molecular formula, so same number of C's and H's, but a different structural formula. And so here's one example of an isomer of hexane. And so what we're basically doing is just taking one of these carbons here on the end, either end of the molecule, and moving it somewhere in the middle as a branch. So in this case, this is going to be 2-methyl pentane. So it is a different structural formula than hexane. It has different properties, but it has the same molecular formula. So let's check your understanding. Can you construct isomers of alkanes? Now let's look at constructing isomers of alkenes or alkynes. These are substances that have the multiple bond, either a double or triple bond. And this is very easy to create an isomer. We're simply going to move the location of the double or triple bond. Just make sure that you're not moving it into the same location as the structure that you're trying to make an isomer of. So looking at this structure here, if I want to create an isomer of this, this has 1, 2, 3, 4. So this is going to be 1-butene. And so to create an isomer of that, I can simply move the location of this double bond to the second position. And so it becomes, in this example here, 2-butene. 2-butene is a different structure than 1-butene, so therefore different properties. It is an isomer of this 1-butene. It would have the same molecular formula of C4H8. So now let's look at drawing an isomer of these alkene or alkynes. So we're going to use the same molecular formula as we did earlier with the alkanes, but in this case we're going to move the location of the double or the triple bond. Again, be careful not to move it into the same position on the other side of the molecule. Remember, you can read compounds left to right or right to left. So here's an example of 1-pentene. So this is 1-pentene, has 5 carbons, 1 indicating the location of that double bond on the first carbon. And so to create an isomer, I first look at the molecular formula, which is going to be 5 carbons and 12 hydrogens. And so I'm going to use 5 carbons and 12 hydrogens in a different structural arrangement. And so it's very simple. It's going to move the location of that double bond. So here's an example here. I move the double bond to the second carbon. And so now this is 2-pentene, that double bond on the second carbon. Now this is the only isomer that I can make by moving this double bond, because if I move the bond here, then I'm also creating 2-pentene. And if I move it here, I'm creating one pentene. Remember, we can read left to right or right to left. So let's check your understanding. Can you identify the isomers of alkenes and alkynes, and can you construct the isomers of alkenes and alkynes? At this point, you should be able to identify the isomers of alkanes, alkenes, and alkynes, and then construct isomers of alkanes, alkenes, and alkynes.